the cos of 105 degrees. Now, I would say to you that, hey, I'm gonna use the sum. So I'm saying this is like cos 60 plus 45. And then now I'm going to have to go to my triangle to understand what are the exact values, because for these, we want to calculate the exact value of, right? So we want to, talking about, have the exact values of. So that's the idea. We want to be able to find the exact value. That means the moment they say exact value, it means that you're not using a calculator to help you to determine this. To write them back so that you can relate to them each time, but you have to start learning to write them yourself. Just as though I'm just going to write it. This is 30. If I put 60 there, this is 1, this is 2, this is the root of 3 with 45 and the 45. This is an isosceles triangle. You could see that's why there's a 1 and a 1, and then that means this is the root of 2. You understand? All right. So now we're going to take the values of those, but now you're still going to go back to your trig ratio. So, tau, combining everything now. Now let's come right here. We're dealing with the cost of these. So you're going to have to represent what cost means first. For example, remember that the cost of the sum is like you have cos 60, cos 45. But remember that then you have a minus sine 60 times sine 45 as this, because that's the only way that we're going to be able to actually put the values that we need based on the special triangles that we're about to use. Cos of 60. Go for the triangle with 60 and the cos of it. See the 60 right there. Cos of 60 is 1 over 2 because cos is adjacent over hypotenuse. 1 over 2. So this part is a half times cos of 45. Come where the 45s are. 1 over root 2. This is 1 over the root of 2. All right. And then we're going to minus sine of 60. Go where the 60 is. This is root 3 over 2. Talking about what is sine. Sine is opposite over hypotenuse. So from 60 degrees, we're talking about root 3 over 2 right there. Then you multiply that by the sine of 45, which is 1 over the root of 2. You could do your rationalizing first because they don't really work with the square root underneath this. They don't really work with these here. So it's best you could work it so that come at the top. So you could do that wherever. You don't have to be a part of this here. So we could do it at the side. For example, we could show that, hey, 1 over the root of 2, if you multiply that by root 2 times root 2, you would see that it becomes root 2 over 2. All right, you would agree? So 1 over root 2 really represents itself as root 2 over 2, rationalizing it because we don't put the root as a square root, as a denominator. So if you're rewriting this, then you will have a half times root 2 over 2 minus. The root 3 at the top is okay, but this one is root 2 over 2. Then now, check it out. This is root 2 over 4 minus root 3 times root 2 over 4. As you can see, we're almost done. When I look at this, check it out. This is the same denominator as 4. So it's like I have root 2 minus root 3 times root 2 all over 4. And then I could go further because I am now able to factorize out the root of 2. What do I mean? Taking out the root of 2, open a bracket, I will have 1 minus root 3 all over 4.